Welcome to day 12 of my Inventor.io 30 Days Lost in Space adventure. Today's lesson is a bit of an extension to the day 11 exercise where we connected the numeric pad and we were able to give it name callouts or numeric callouts in the serial monitor based on which button we would press. So we have this 4x4 numeric pad hooked up, and in this lesson we have this buzzer. So the buzzer connects to the hero board. We have a ground rail that shares a ground connection to here. This is just a pin that goes into any of these selections on the areas of the common rail. If you look at the buzzer itself, it actually shows you which pin is which. So I have my output coming from here, going to the input on the buzzer, and then I have my ground going out to the common rail that ties to here. So nothing crazy going on in wiring land. So let's take a trip over to the computer view and we'll go over the code, because the code is pretty complex but the physical connections are not. Okay, so looking at the code after watching the video, a lot of the stuff is similar to the day 11 code, but you'll notice that there are a couple of things that are different. In my program, I put a pound define buzzer 11. In theirs, they put an integer buzzer equals 11. Similar in definition, because what this define is doing is it's defining a constant value to buzzer, which is 11. So that's the only real difference between my code and theirs. This part is the same. Constant byte rows and calls with the character array for the number pad. This is also the same. One thing that got added was this int tones with rows and calls. So this int tones rows calls is calling up an array with different tone frequencies that are called from a tones table that is resident in the Arduino IDE. The keypad callout is pretty much the same. The void setup is pretty much the same. But down in here is where it gets a little bit different, or a lot of bit different, really. So I'll go back to this, and just because I like to do this over, include .keypad.h pound define buzzer 11. When you're doing a pound define, you don't put an equal and you don't put a semicolon. Create a constant byte called rows equal to 4, constant byte of calls equal to 4. I noticed something when I was playing around with C language proper, and that is I don't know if it's the inability to, or if I'm just doing something wrong, but there is a lack of ability, for lack of better terms, to create an array such as this, where we have the number constants up here, and then we just call up rows and columns in the array here. I can't get it to work in C language proper with Genie, so I have to define number of rows as 4 and number of columns as 4. I didn't copy this exact thing, but just as an example, rows and calls. Doing a multi-dimensional array in C language, I had to forcibly put the numbers here, as opposed to being able to assign them to number constants here. So that is something that is a little bit different from Arduino to C language proper. But I did get clarification. My notion of multi-dimensional arrays not really caring about the spaces or the carriage returns like we have here You can put them in a single line and then just separate each of the arrays with a comma. But it makes it easier to read when you break down a multi-dimensional array into its respective rows and columns, such as you see here. So it's more of a visual. I also learned that you can create up to 32 dimension arrays. So that would require putting another bunch of values here, up to 32. And a three-dimensional array would be cool in an Arduino because you could create a three-dimensional array and you can create a cube of LEDs as long as you have the proper number of pin assignments. And you could create a big old LED array cube that would dance around to music or what have you. So there are a lot of interesting things you can do with arrays. And if you haven't seen it yet or heard of the page yet, I do highly recommend watching a page called Dave's Garage, because Dave's Garage has a lot of really interesting information. He's an old computer programmer from Microsoft, and he tells a lot of stories about his time at Microsoft and a lot of things that he developed. He's the developer of Windows Task Manager and zip folders within Windows itself without having to use a third-party application to work with zip folders, and a real bright guy. But yeah, check out Dave's Garage if you get a chance. I've gotten stuck in quite a few YouTube holes watching his stuff. It's really good content. Now you'll notice that right here I have this pin mode tones comma output commented out. The video points to using a pin mode here, but when you try to do it that way and you compile it, you get a warning. Not so much an error, but you get a warning. And if you take it out, the board still works, everything still runs fine, but you don't get the compile error. I'll show you that right here. You may not like that I have the serial stuff enabled without plugging in the board, so let me plug that in and then I will compile it. You'll see right there I get a little bit of a warning shot. It's like, hey, you have an error with something. It says invalid conversion from integer to uint8_t, which is an unsigned char. Removing the pin mode, like I said, compiles it no problem. There's no warning, and then when you upload it, it does work. So I don't know why that is, but I just know that to be true. I know these truths to be self-evident. Not much going on in the setup. Inside of the loop, we have a variable that is an integer called tone freak, which is funny because a tone freak or a tone chaser is something that they call musicians that are constantly chasing after the perfect guitar tone, mostly for guitar players, bass players. Those guys tend to be tone chasers, and they'll spend their entire lives trying to find that perfect tone. Billy Corgan from the Smashing Pumpkins is a self-proclaimed tone chaser, and quite frankly, all he really had to do was just stick with his Siamese Dream guitar tone, and I think the world would still be happy with their music. So we have this tone frequency integer. We establish it with a 0 value. We have a custom key char, which is just a character variable linking to custom keypad.getKey. Inside of here we have, if custom key is pressed, it'll serial print key. and then it'll say what the custom key is that is being pressed. That's just for the serial monitor, like we had in the day 11 lesson. But underneath that, we have this embedded for loop. So for byte j equals 0. So inside of the for loop, we're declaring that variable j is a byte. And if j is less than rows, count j plus plus. Inside of that, we have another for loop. So that is a 2-level embedded for loop using I and j variables, one for rows and one for cols. And what this does is it just continually scans the rows and columns for button presses and outputs the tone accordingly for the button that you are pressing. So if custom key equals buttons, j for rows, I for cols. Personally, I would have done I for rows and j for cols, but I just followed the lesson code. Then we output tone frequency equals tones j and I. So whichever button gets pressed, output the tone frequency from that row and column inside the character array up here. And then what a break does is when the code sees a break statement, it breaks out of the for loops and continues on through the order of succession within the program. Because C language cascades from top to bottom until you hit these for loops or while loops. For loops and while loops are very similar, but for loops are a little cleaner, where you don't have to predefine the variables and write all kinds of stuff. You just put for, and then you could define the variable inside the for. So to do this as a while would be, say, int j equals 0, while j is less than rows. Then you'd have to put your stuff, but then you'd have to say j plus plus, or you could say j equals j plus j. Something like that. So this just cleans it up a little bit. So it's saying while j is less than rows, do this, count up. And then inside of here, just define and declare the variable with the starting value. From there, we output tone, again, which is an internal command within the Arduino IDE. So we output a tone from buzzer, which is pin number 11. The tone frequency comes from the table. I'm not quite sure what the 500 is for. I thought it was a delay time, but it doesn't seem to be the case. Yep. And then no tone is just a way for the Arduino to disable this line right here. So you press it, I have it set to a delay of 100 milliseconds, and then it does a no tone, which is basically setting the tone to false. So I'll compile, see if I made any mistakes. Seems to be good. I'll upload that. And then when I press the buttons, I get a lot of beeps and boops. If I lengthen the delay a little bit, you can hear it beep and boop a little bit longer. Could set it up for 1 second delay. So each one will take a second. Doing it that way won't let you overlap, so it's only one at a time. And just as a quickie here, if I change that to an integer value, it still works the same. You'll notice that there were no errors going from int buzzer back to define. So it's basically the same thing. From what I understand, there are cases where pound define or constant integer will take up less space, but it does seem to be the same no matter what I do. That's pretty much it for this lesson. I did scan ahead and I looked at the lesson that comes up after this, and the one that comes up after this is very in-depth. So I'm looking forward to revisiting that for the sake of the recording and going over it piece by piece, because I just kind of crunched the stuff in, plugged everything in, and was able to make it do what it was supposed to do for that lesson. But there is a lot to go over inside of that lesson. What they're doing in the next lesson is building a keypad that stores password values and will prompt you on the serial monitor to either input an existing password or change to a new password, or there's a bunch of different things that are going on. And the code does get very in-depth. So stay tuned for that one. I'm going to be recording that video in the next couple of days, and hopefully doing that will help it set in a little bit, because it did get a little overwhelming when I was putting the stuff in. I was looking at it going, oh boy, there's a lot going on here and a lot to keep an eye on. So if I did have one suggestion for them, would probably be to incrementally build upon that before getting to this day 13 exercise, because the day 13 exercise compared to day 11 and day 12 is like miles ahead of day 12. But that's just me, and I'm not as young as I used to be, so retaining this stuff is a little trickier than it used to be. I freely admit that. But I am learning a lot, and even just picking up the books and stuff that I have on C language that I bought 25 plus years ago, looking through that is a night and day difference from when it was when I first picked up that book when I was 16, 17 years old. And I said, oh my goodness, what the heck is all this stuff? So this is proving to be very helpful. It's just going to take me a little while for it to sink in. So thank you for watching. I hope you're enjoying the content. Please be sure to like and subscribe. If you have any suggestions for upcoming videos, please let me know in the comments. As a side note, I was chosen to be a beta tester for new Inventor Corp products. So there's going to be a lot of videos based on that stuff coming up. I am very excited about it. I was one of 10 people that got chosen to be part of their beta program. So it's very exciting. I'm beside myself that I have the opportunity to help out with the upcoming lessons and things that are going to help the rest of the community and those trying to get into electronics and computer coding and things like that. I'm not in this for any profit or anything like that. Although if you do click on an affiliate link and order something, I do get a couple of cents towards the page, which would be fantastic. But all in all, I'm not in this for any kind of profit. The stuff that they're sending me is simply to help them. They're not going to compensate me financially. They're just sending me a toolbox full of sensors and boards and wiring and stuff like that to help them build their company to provide products to help others who want to learn this stuff. So keep an eye out for that content in the near future. Also, even though this is just an Arduino video, keep an eye out for a review on a CNC tool presetter that I'm going to be receiving very soon from EMG Precision. That's going to be part of my mini mill build, but chances are I may put it on my CNC router just to test it out before I put it onto the mill, for the sake of helping out EMG Precision, because my mini mill isn't quite ready for a presetter just yet. So to do an initial testing, I'm going to more than likely put it on my router and see what's what with it. But anyway, thank you for watching, and we will see you soon.